Hello everyone. We will continue our learning of Chapter 7, Consumption, Saving, and Investment. For Part 2, we have 3 targets. One is to understand asset accumulation, and we will also learn how to put down proper time subscript for household budget constraint. And then we'll move on to build up households intertemporal budget constraint and finish it with the idea of present value. Now we want to talk about asset accumulation. To think about asset accumulation, we need to think about a timeline. So imagine you are standing here today. So relative to today, we have yesterday and tomorrow. And we like to use the number 1 to denote today, 0 for yesterday, and 2 for tomorrow. In each period, suppose we stand in today, then there will be a budget constraint that we have learned before. In this budget constraint, there are 3 things that the household has to decide today. The first one is how many hours to work, which is L. Therefore, we put down L1. The second thing he has to decide is how many consumption baskets he has to consume. So we put down C1. The third thing he has to decide is how much money to set aside for investment, which is delta A1. However, the income from asset part, that asset A is predetermined, which is the asset that's left from yesterday. So we put down A0. Once we put down A0, it means that this number cannot be changed today. It is predetermined. And now if we put back all the price, and then we will recover the household budget constraint with time subscript. So we can move on to talk about asset further. In today's household budget constraint, household would inherit some initial asset which is related to his investment decision from the past. So up to the beginning of today, there should be some asset accumulated. Suppose the asset value at $1 million. Then what can this $1 million initial asset do for the household today is that the first thing is there is an interest return. So if the interest rate is 5%, then it's implied that this 1 million asset is able to generate some asset income of 0.05 million, which is simply the initial asset value times the interest rate. The second thing that the initial asset can do is for future asset value accumulation. Remember that today, household also has to decide how much more money to invest in assets, which is delta A1. If the household decided to invest $0.5 million on assets, it would imply that when we move on to tomorrow, then the initial asset value that tomorrow is going to inherit would be A1, which would be equivalent to the value of 1.5 million. Now we put both today and tomorrow's budget constraint together, you will be able to compare the change of time subscript and understand why we use 0 and 1 and 2. And now I also put down the initial asset value for both today and tomorrow. For today, the initial asset value is 1 million. And we know that this initial asset can do 2 things. First, it can generate the asset income for today's household to spend. Secondly, this initial asset can be moved to tomorrow, become part of tomorrow's initial asset. However, that's not all the initial asset value for tomorrow. part of the initial asset value comes from today's investment, delta A1. So both together, when you sum them together, which would give you A1. Therefore, we get the asset accumulation equation. A1 is equal to A0 plus delta A1. Now we are ready to move on to talk about a new kind of household budget constraint, which is intertemporal budget constraint. By definition, intertemporal means anything involved with more than one period. We start from our traditional one-period budget constraint. For today, we use notation 1, and we already know that how to denote the income inflow for today as what we show on the slide for the piggy money. And we know that for today, the way you can use this income source is to either consume it or to save it. Then we can formulate the one-period household budget constraint. Now we put two periods of household budget constraints together on the same slide. Then on this slide, if you look at tomorrow's budget constraint, you will notice that the asset income IA1 has a component of initial asset A1, which actually comes from today's decision, which is delta A1. We know A0 is something happened in the past, so you cannot change it today. So anything that happened on today's asset purchasing, it would immediately affect tomorrow's asset income. And consequently, it can affect households' consumption planning for tomorrow and continuously to the day after tomorrow, so on and so forth. So one way households think about consumption plan is instead of doing the plan period by period, household might think about how about pulling today and tomorrow's income source together and then try to plan 2 periods consumption decision altogether instead of doing it one by one. By thinking about things in this way, household is actually contemplating about something we will call intertemporal household budget constraint. But for this kind of planning, we have to figure it out first. What is inside this piggy money, and what will be the remaining money that's unspent? What should we call it? Okay. First, we move on to the content of the piggy money. And now we have 2 periods, today and tomorrow. So for the possible income sources for today, the money can go into the bucket is that first, we know there is labor income. That definitely would go into this 2-period piggy bucket. And then there will be interest income from asset that will also go into this bucket. And for tomorrow, we are pretty sure that there would be labor income goes into the bucket as well. And is that all for 2 periods? Actually, that's not all of it. Because we know that for the interest income that goes into the bucket today, actually it is generated by the initial asset holding that we have. And we know that the initial asset that we are holding, actually it has some kind of market value, which we call as A0. So this value, if the household wants to spend it for the future and today, the household can actually sell the entire machine. After they obtain the interest income, they will get the A0 money back. Therefore, actually the total sources that the household can obtain to use for 2 periods should include A0 as well. So actually now for today's money source, we have both labor income and also 1 plus I times the initial asset value. And for notation simplicity, we will use A1 tilde to represent this initial income and wealth contribution from the past. And also we will use I1 and I2 to represent the labor incomes from today and tomorrow respectively. That's just for simplicity. Otherwise, we have to write down a lot of notation in our following lecture. Okay, so what we have so far is that in this piggy money, there are two income sources from two periods. From today, there is income I1, which is labor income. Also, we have initial asset wealth that also goes into the bucket. From tomorrow, we will have I2, which is labor income. Therefore, when household is conducting a two-period budget constraint planning, the money in the piggy bucket will contain A1 tilde plus I1 from today and I2 from tomorrow. So given these buckets of income sources, then for today, household can spend some part of today's money on today's consumption, and then the remaining part on today's cash pile will be A1 tilde plus I1 minus PC1. And this part of money, actually you can save in the bank, and in the next period, it would give you interest. So together, this part of money that you move for tomorrow's usage would be 1 plus I times the part of money that you did not spend today. So this part of cash, you can combine it to tomorrow's income cash. That will be the total cash that you can spend tomorrow. For tomorrow, you would use part of the money for consumption. And then the question is, what should we call the remaining pile of money that is not used? In the past, we call it saving, but here, should we call it saving? That's the question. So we consider what exactly is inside this unspent pile of cash. Remember, when household conduct a two-period planning, then when he calculate how much cash he can own, actually part of it comes from his initial asset value, A0. So this part actually, unspent part of it actually represent A0. If you still have some money left unspent, which means that you must use this to accumulate your asset. So you bought more asset tomorrow. Then when you buy more asset tomorrow, altogether, which means that by the end of the day, you will have this much cash value of a machine and bonds, which means this much value of asset. These asset represents the end of tomorrow's asset balance that you are going to have. So the notation here should be A2, sorry, it should be A2. Therefore, the second period spending pattern represents an intertemporal budget constraint that can be written as the following red-colored equation. So you have on the left-hand side, you have I2, the wage income from tomorrow, plus the unspent part of money from today times its interest plus 1. This will be the total amount of cash that you could use for tomorrow, and it should be equal to tomorrow's consumption expenditure plus the remaining part that represent the balance asset value that you are going to own by the end of tomorrow. This is the intertemporal household budget constraint for two periods. Now we talk about present value. To think about present value, we think about the income sources for intertemporal budget constraint. We have A1 tilde plus I from today. We also have I2 from tomorrow. And to think of present value, we start to talk about our money spending plan from tomorrow. For money that we use for tomorrow, we can either use it for consumption or keep it to be the part of the remaining asset balance. So these are the money that we can use tomorrow. That's the only two options that you can have. However, if your income flow from tomorrow is I2 and after you deduct your expenditure and asset balance part, there's still one pile of cash left, then what can you do with that? Because any cash tomorrow can only be used for consumption or to build up asset, if it's still left a pile of cash tomorrow, it means that somehow the household is able to use this pile of money today. But how can the household do so? We have to imagine one way that the household can do is to issue a piece of paper called IOU. So if the household want to spend D1 and he can issue IOU or use his cash, but in this case, if the household issue IOU, he can find a banker who has the D1 that you want and exchange the IOU of D1 with the real cash from the banker. Then tomorrow, the banker will look for you and will ask you to pay back not only D1, but D1 times 1 plus I, because the banker will require some interest payment. So through the entire process, actually somehow you move your 1 plus I D1 cash from tomorrow to yourself. However, the money you move to today, you only get D1. So, in summary, by doing this borrowing and payback process, you are able to move 1 plus I D1 from tomorrow to D1 today. Therefore, $1 from tomorrow is equivalent to 1 divided by 1 plus I today. So, if the household know that he would have a pile of cash unspent, from tomorrow he can move it to today for today's usage. However, any amount of money he moved to today would be deflated by dividing it by 1 plus I. So actually the money value will shrink. So the total amount of money that you can spend today would be actually the income source from today, A1 tilde plus I1, and plus the additional pile of cash you move from tomorrow to today but deflated by 1 plus I. And this pile of cash will be the amount of cash that you can use it for consumption today. And therefore, we can rewrite the intertemporal budget constraint from present value point of view. It will look like the equation on the top of the slide. So far, we have learned two ways to write intertemporal budget constraint. One is thinking about moving our money source to the future. Then we end up with an intertemporal budget constraint like this one. Here, we look at the future. Tomorrow, we have I2 cash plus any unspent current money that we move it, we save it for tomorrow's usage. That's why we times it by 1 plus I. And totally together, this part of money can be used for future tomorrow's consumption, PC2, and with the part left to build up your asset balance, A2. The other way to think about intertemporal budget constraint is to think about borrow or move future money for the present. Then we end up with an intertemporal budget constraint like this one, where we have A1 tilde plus I1 for present income source from today, plus extra money that move from anything we did not spend from future, we move it to today. However, if you move any future money to today, you have to discount it by dividing it by 1 plus I. So totally together, this will be the total amount of cash that you can use for today's consumption, PC1. So for this present value expression of intertemporal budget constraint, if you rearrange both sides, you will end up with this intertemporal budget constraint expression. In this expression, the part on the left-hand side represents the present value of intertemporal incomes plus the initial wealth. So you can see that any income source from the future will be discounted. But income source from today, we don't need to discount it. And this part of a present value is your present value income source for 2 period, which you can use it for any kind of expenditure for the entire 2 period, plus the balance of asset at the end of period 2. So the things on the right-hand side represent the present value of your intertemporal consumptions, plus the ending wealth balance. And if you look at the consumption part, PC2 is from future, so it has to be discounted. And also, the ending wealth balance is the balance from future. Therefore, it also has to be discounted as well. For this budget constraint, there's one thing I want to remind our students again. Here, the initial wealth, A1 tilde, actually is not something the household can control today because it is equal to 1 plus I times A0. So it is the thing that you decide from the past.